Hi there, and welcome back to Basic Math for Economics. In this video, I want to show you one of my favorite math tricks that I've used countless numbers of times when I've been working on problems, and that's called invoking symmetry. So this is a great technique that's going to allow you to quickly analyze specific systems of equations without having to go through and substitute through all of them and really make a pain out of it. So like I was saying, this is a really neat trick. So basically, we can use symmetry when we have agents that have symmetric objective functions. So the whole idea is that if the people making the choices are essentially the same, like from their perspective, they're facing the same decisions, we can actually assume their choices will also be the same, because why would they choose anything different? If they are facing the same costs, if they're facing the same objectives, they're going to make the same decision. So what will happen is that's going to very easily make our analysis something that we can work with, something that can work through much quicker. But there is a bit of a drawback. Symmetry can only be invoked during very specific circumstances, and it has to be done correctly or you're going to run into problems. So we need to talk about those. So anyways, let's look at this through an example. So let's suppose we had three firms that competed in a Corno context, and they faced the following inverse demand function right here, where price equals 100 minus Q1 minus Q2 minus Q3, where of course Q1, Q2, and Q3 are firm 1, 2, and 3's quantities respectively. At the same time, firms are going to face a constant marginal cost of 20. So let's calculate our equilibrium output for each firm. So anyways, let's set this up. Let's start with firm 1, set up their problem. Now, again, firm 1, their only choice they get to make is their own quantity. They get to choose Q1. They're going to maximize their own profits, which of course the price is a function of all three firms' output levels, but it's going to be times firm 1's quantity minus 20 times firm 1's quantity again. Now I can do this, and I can set up the profit maximization problems for firms 2 and 3. And if you'll notice, they look really similar. In fact, they are symmetric in this case. If I just took Q1 and switched it with Q2 or switched it with Q3, I would get the exact same function. Really, if all of the subscripts, where it's the 1, 2, and 3 on the Q, if I can switch them around and get the same functions, then we have symmetric functions. And that's one of the requirements for invoking symmetry, in that we have to have agents with identical objective functions, or symmetric objective functions. So you might be wondering, what wouldn't be symmetric? Well, let's say one of these firms faced a different marginal cost function. Then they wouldn't have the same objective function. They would not be symmetric in this case. But because they all face the same demand function, they all face the same constant marginal cost, they are indeed symmetric. So from here, I can calculate a first order condition for each problem, just like we did in the last lesson. And for firm 1, I get 100 minus 2Q1 minus Q2 minus Q3 minus 20 equals 0. For firm 2, I get 100 minus Q1 minus 2Q2 minus Q3 minus 20 equals 0. And for firm 3, I get 100 minus Q1 minus Q2 minus 2Q3 minus 20 equals 0. And again, it's the same thing. I could rearrange my subscripts, and all of these equations would just become one another. So they are indeed symmetric. But looking at this, though, this is a system of 3 equations and 3 unknowns, and that would actually take a while to solve. We'd probably want to use a matrix, work through it, and do our reduced row echelon form. But since these are symmetric, I can actually very quickly solve these. And that comes from the idea that since these firms are identical, they're facing the same situations and the same costs, I know their solutions should be identical as well. So why don't we just assume it in the first place? Assume they're going to do the same thing. So what I'm going to do is I'm going to assume that Q1 equals Q2 equals Q3. I'm just going to call it Q in equilibrium. And that in equilibrium point is really important. They're going to be the same value in equilibrium. So I'm going to substitute in Q for all of those first order conditions, and they're all going to collapse into the exact same equation. 100 minus 2q minus q minus q minus 20 equals 0. Or if I combine terms, I'm going to get 80 minus 4q equals 0. And that is just one equation, one unknown, one of the easiest ones we could possibly solve. And that's way easier to solve that system of 3 equations and 3 unknowns. In fact, I just rearrange it and divide by 4. I'm going to get that q star, and of course, which is also equal to q1 star, which is equal to q2 star, which is equal to q3 star, is equal to 20. And we're all done. That's it. That is our solution right there. If I went through and I solved those 3 equations and 3 unknowns out, did the substitution or the reduced row echelon form, that is the exact value that I would find. But I was able to invoke symmetry and solve it in about 2 steps, which is fantastic. So, like I was saying, invoking symmetry is a very powerful technique, and it's going to save you a lot of time when analyzing this kind of problem. But it has 2 significant requirements, and you have to remember these requirements if you're going to invoke symmetry. The first requirement is that the firms must have, or agents must have symmetric objective functions. So they have to be, for the case of profits, they have to be facing the same demand function. They have to be facing the same marginal costs, or else we can't do this. We have to do it the other way. And second, and the most important one that people forget the most, don't invoke symmetry until after you calculate first order conditions. They are equal in equilibrium, and a first order condition is an equilibrium condition. If you make the mistake and do it before you calculate the first order condition, you will get a different solution. In fact, it'll bring you to what we call the cartel solution, and that's not what we're looking for. I see this mistake made often on questions and on exams, so make sure that if you're going to invoke symmetry, you do it after you calculate first order conditions. Anyways, I hope this technique works out very well for you. Definitely worked out very well for me, and that's actually all for this video, so thanks for watching.